Welcome back to Logic Basics. We are in the middle of talking about judgments, particularly categorical propositions or categorical statements. We're going to go right into the handout here. And in the last session, we went over the square of opposition. We saw where these judgments are placed. All S is P, no A, E, I, and O statements. Remember, all S is P is an A. No S is P is E, some S is P is I, and some S is not P is O. And we saw several versions of the tricky O statement. I want you to memorize those. Know those forever. And then we need to talk about these lines on the square. What do the lines represent? Why is it a square of opposition? So the lines represent different relationships among these judgments. So the top two, the relationship is called contraries. Contraries. The bottom two are sub-contraries. The diagonals are contradictions, and the up and down are called subalternates. Okay, now you need to know those relationships, but there's rules for those relationships. And I'm going to go down, we're going to lose the square for a minute, we're going to go down here and we'll see how they're related. So the categorical propositions may be related to one another by use of the square of opposition. So I will try to draw your attention to it, but maybe you can have the handout in front of you while I go over this. So contradictions are the diagonals, okay? Diagonals. Contradictions are two diagonals. A and O, all or some is not, and E and I, none or some. Okay, here's how we're going to define a contradiction. So that may be one of the questions you're faced with on an exam, perhaps. What is the definition of a contradiction? So contradictions differ in quantity. How much? Okay, quantity is either universal, all or none, or particular, some. Some is particular, okay? So they differ in quantity, how much, and they differ in quality, is or is not, affirmative or negative. So if you notice on the diagonals, the A corner is an all, the O corner is a some, the A corner is an is, the O corner is a is not. And when you flip it and you go to the other one, the E corner is no, and the I corner is. This is all, universal, none, this is some. So they differ in quantity and quality. That's what makes them a contradiction. And I'm emphasizing this because when we're arguing, when we're having a dispute or settling a dispute, oftentimes we fail to identify a contradiction and we end up arguing something else. So I'll show you what else we could be arguing. Now, here are the rules for contradictions, also a question I may ask on an exam. By the law of non-contradiction, contradictory statements cannot both be true and they cannot both be false. Now think of the apples example. All apples are red. Pretend that's true. Some apples are not red. That will not be true, right? Or if you say some apples are not red, I have a green one, then all apples are red can't be true, right? So these can't be true at the same time. Just plug in your apples in the example there. An example of a contradiction, all apples are red and some apples are not red. So I guess I did write that down there. Now, remember I just said that people can get stuck arguing things that are not contradictions. They could argue contraries, and this happens all the time. This is where that binary thinking can come up again. Remember we thought binary thinking is bad? Here's where the binary thinking probably originates in contraries, which is the A statement on the top and the E statement on the top. Two universals, but they could both be false. For example, all apples are red and no apples are red. We know those are both false. If I go to the grocery store, I'm going to find some red apples and some non-red apples, right? So those two on the top can both be false. So that's probably where this question about binary thinking is coming up. People arguing two false judgments. So the rules for contraries, both may be false, both cannot be true at the same time. If all apples are red is true, no apples are red is not true. It's false. Okay, the subcontraries, remember the bottom two, the I statement and the O statement, these may both be true, but both cannot be false. So it has to be one or the other of those is true, or they're both true. For example, with the apples, if I go to the grocery store today, some apples are red is true, some apples are not red is true as well. So those two can both be true together. They can be. They don't necessarily have to be, but one of them has to be true. And then the subalterns are the top and the bottom, the line from top to bottom. This is the A and the I and the E and the O statements. Now here's the rule. If the universal statement is true, the statement on the top, the all or the no, if that's true, then the particular is also true, the one on the bottom. So if all apples are red is true, some apples are red is also true. If no apples are red is true, some apples are not red is also true. But we can't go the other way around. If the particular statement is true, the universal statement is doubtful. We don't know. So let's say I have a basket in my office of 5 red apples. This basket tells me some apples are red, these ones. But can I infer from these red apples that all apples are red? No, that's the mistake. So I'm going from particular, the ones that I have, to a universal, all of them. That's a mistake. It's the fallacy of generalization. It's going from a particular to a universal. We can't do that. All right. So you can't read from the bottom up the square. You can only read top down. So think of all includes some, but some does not necessarily include all. Okay, so we're going to take some time to think about these rules, put them on a note card, memorize them, be quizzed on them, and we're going to use them. We're going to use them over and over and over again. Now let's wrap up this handout. The meaning of a proposition must be understood prior to affirming or denying the truth of the proposition. So we might have a proposition, all apples are red, where we have to go, what does that mean? So we have to analyze the concepts used in a proposition, and that will help us to determine the meaning of the proposition. Once we have the meaning of the proposition, then we can plot it and understand it when we plot it on the square. To oppose a proposition, it is necessary to establish its contradiction. So the differing quantity and quality both can't be true, both can't be false. So we want to establish a position. Let's say I want to establish material monism is true. Then I have to show the contradiction. Only some is eternal theism. All right, now the example I gave you here, no apples are red is opposed by the statement some apples are red. Okay. Now you're going to have to start thinking in terms of the square and judgments plotted on the square. Judgments are evaluated by their truth. Understanding the meaning of the concepts used in a judgment is prior to evaluating a judgment as either true or false. So we first have to know what does it mean, and then test to see whether it's true or false or doubtful. Okay. Failure to seek agreement on the meaning of the concepts being used in a judgment will result in a lack of agreement on the truth value of the judgment being proposed. If we don't agree on the terms, we are not going to agree on the truth claim. And then lastly, failure to identify the contradiction of a judgment that one opposes may result in opposing a contrary position, and contraries may be both false, leading to a false dichotomy, or leading to binaries that are both false. Okay? So we want to answer these questions now. At the end of this handout, you should be able to explain what a judgment is. You should know what the 4 basic forms of categorical propositions are, A, E, I, and O, and what they look like. You should be able to define contradiction and give an example of a contradiction. So I use the example, all apples are red, and its contradiction, some apples are not red. You should come up with a contradiction of your own making, where it's all S is P, where you fill in S and P, and or no S is P, you fill in S and S and P and give the contradictory position. You should be able to define contraries, subcontraries, and subalterns at the end of this handout. And how are propositions opposed and how are they evaluated? Okay, so that's your job. Answer these questions, think about it, and this will be our segue into formal logic. It's going to be difficult, it's going to hurt your head, and that's good for you. Before I do the formal logic, though, I want to do one last handout like this, and it's on arguments. What are arguments? So we're going to use judgments to build arguments. So we make a judgment and we need to support our judgment. Arguments are how we support judgments. And so we're going to do that right before getting into the formal aspect of logic. So I'll be back with that handout.